that would count how many elements there are in the array. And you might be thinking, well, why don't you just say the array name dot length? And that's because it's not really, I mean, it is an array, but what we're really counting is how many elements there are in the sound object, because a sound object is really an array of integers, okay? So that's why I included that additional method there. But let's take a look at part A. So part A, we're told that the volume of a sound depends on the amplitude of each value in the sound. The amplitude of a value is its absolute value. For example, the amplitude of -2300 is 2300, and the amplitude of 4000 is 4000. Write the method limit amplitude that will change any value that has an amplitude greater than the given limit. Values that are greater than limit are replaced with limit, and values that are less than negative limit are replaced with negative limit. The method returns the total number of values that were changed in the array. For example, assume the array samples have been or has been initialized with the following values, okay? When the statement int num changes is assigned to limit amplitude 2000 is executed, the value of num changes will be 5, and the array samples will contain the following values. So two things are happening here. The first is that a call to the limit amplitude method will count how many values in the array are, we'll just say are greater than the limit, okay? And that's the absolute value of each of those values. And then secondly, what will happen behind the scenes is that each value that is greater than the limit will be reassigned to the limit or reassigned to the negative of the limit if the number that was in that slot was negative and was greater than the limit in terms of absolute value. Okay, so for example, 2,532 is reassigned to 2,000. -2300, the absolute value of -2300 is +2300, and because that exceeds the limit of 2,000, the element at that position gets reassigned to -2000, and so on and so forth. Okay, so we have our method here, limit amplitude, int limit, which is the parameter. So we're returning an integer that counts how many elements in the array exceed that limit in absolute value terms, okay? So I have a count variable that's going to count how many times this occurs. Now, if you used APCS Awesome, it had a couple multiple choice questions there that sort of guided you in how to set up your code for this. So of the 3 loops that we know how to use, the for loop, the for each loop, and the while loop, the for loop is the best. Now you might be thinking to yourself, well, in line 14, what I'm seeing is the very standard for loop where I'm starting from the left, I'm ending all the way at the right, and I'm looping through each and every element. So wouldn't I be able to use a for each loop? Well, if that was your initial thought, you're not wrong. One of the drawbacks of the for each loop is that the for each loop abstracts this piece of information away, samples at I. And what it does is we create a variable like element where we say for each element in the array, and then we do something, okay? With a for each loop, you're not able to reassign the actual element at a specific position to a new value. And thus, the for each loop cannot be used here, okay? You might be thinking to yourself, well, I can say element is assigned to limit. Yes, but element is sort of it's a reference to the variable and almost in a copy sense. It's not the actual element itself. So all you would be doing is changing the value of some variable element, not actually changing the value of an element at a specific position within the array, okay? And on our last exam, there was a multiple choice question like that we went over, and a lot of people got that wrong, okay? So again, if you're going to use a for each loop, the for each loop is strictly good for going through an entire data structure and basically just printing what's at each position. If you're going to reassign values within the data structure, then the for each loop is no good, okay? And then, of course, if you were going to only loop through part of a data structure, the for each loop is no good. And the while loop could be used here, but would make things more complicated because you'd have to keep track of the index variable and when and where you would be incrementing it. So it's not that you can't use the while loop, it's just that it's much easier to use the for loop here, okay? So if samples at position I is greater than the limit, then we're going to reassign samples at position I to the limit, and we're going to increase the count by 1. Else if the absolute value of samples at I is greater than limit, then we're going to reassign samples at I to the negative of that limit, okay? And then we're going to increase the count by 1 as well. And then finally, we're going to return the count. So if we check out the main method, and we have an array of integers that's given to us in that example right here, okay? And we create a sound object with an array of ints. So we're going to call that sample right here in line 7. We have the num changes variable, which stores an integer value. And by saying sample dot limit amplitude to 2000, and then system dot out print num changes. Go ahead and run this real quick. So we got 5, and as we can see, there are 5 values that fit that criteria. So 1, 2, 3, 4, 5. Okay, so that worked out just right. And then secondly, we want to print the array after having made the call to the limit amplitude method, because not only does the limit amplitude method change anything that exceeds 2000 in absolute value terms, not only does it count how many there are and values that are above 2000 in absolute value terms, it is supposed to reassign that element to either positive 2000 if it was a positive number, or negative 2000 if it exceeded 2000 in absolute value terms. So let's go ahead and check this out. And we can see, so we have 40, okay? And then positive 2532 was changed to positive 2000, good. 17 stayed at 17. Negative 2300 was changed to negative 2000, good. Negative 17 stayed at negative 17. Negative 4000 became negative 2000. 2000 stayed the same. 1048 stayed the same. Negative 420 stayed the same. 33 stayed the same. 15 stayed the same. Negative 32 stayed the same. 2030 got reassigned to 2000. Perfect. And 3223 got reassigned to 2000. Okay. And I was able to just say system.out print sample, which is the sound object, because I included a toString method in my sound class that took a blank string. It took the array, and it took each value in the array and converted it to a, not converted it to a string, but it took that element, and it essentially converted it to a string, adding it to that blank string so that it would print out all of those values for us nicely, okay, and then returned array string. So I know Tamim, you had asked me about this. That's why I didn't particularly love the way that APCS Awesome set it up, because it was just not really compatible with how we've been setting things up in Replit. So I just decided to make my own two-string method that just took a blank string and took each element from the array and put them into that string, basically. Okay, so what you see here is really a string, and that little space there, I can actually get rid of that by, instead of having this setting it to a string with a space, literally just have it a blank string, and you'll see the difference in just a moment. Subtle difference, you may not even notice it, but yeah, now the 40 is lined up with the 5 as opposed to having one space over. Okay, so are there any questions related to part A? Anything that you still don't understand from part A? You're welcome. Does anybody need to see anything from part A that wasn't covered, or something that you just still don't understand? Okay, good. We're gonna move on to part B then. And part B says recorded sound often begins with silence. Silence in a sound is represented by a value of 0. Write the method trim silence from beginning that removes the silence from the beginning of a sound. To remove starting silence, a new array of values is created that contains the same values as the original samples array in the same order, but without leading zeros. Now, I have a confession to make. When I first did this problem, I glazed over that. I went over that too quickly, and I didn't really look at this carefully enough. And I thought that the problem was just asking us to get rid of all of the zeros, which would have been much easier, in my opinion. But it's not asking you to do that. So a 0 represents a silence, okay? So, within a recording, there may be silence, a pause, right? But what they want is they want the silence at the beginning of the recording to be eliminated. So any leading zeros must be gotten rid of, okay? So that's our objective here, to get rid of these leading zeros and then return the original array. Now, I think earlier this week, it's all sort of like, morphing together, but we definitely did an example similar to this, where we had an array and we had to create a new array where we sort of like copied only specific values or specific objects over. And then at the end of that method, we had to reassign the original array to the new array. So again, there's an example of something we did from a previous question that can be applied to another question. That's why I keep saying you gotta keep going over these problems over and over and over again. You can't just, once you do one, just put it to the side and say, oh, I did that, I don't ever have to do it again, okay? It's really important that you go back and look at those older problems that we've already completed. So let's take a look at the trim silence from beginning method, okay? And my first objective here is, or the first thing that comes to mind is, how do I create a new array with a specific size, and knowing that I could be given, different examples of arrays with different lengths or different sizes, okay? So I can't just say like, oh, make it, hopefully we've gotten way past this, but when they give you an example like this, they're not saying, oh, okay, the original array has 15 and the new array will have 11. That's just one example. They're not saying that that's the way it's going to be for this method every single time. Okay, that's not what's happening. So hopefully you didn't write, oh, my new array has a length of 11. Hopefully you didn't do that. Okay, we have to do it in the abstract. So again, my goal is to figure out how many leading zeros there are, and then subtract that number from the length of the original array. That will give me the new length of my new array every single time, okay? That's what we're trying to build here. We're trying to build a method that will work on arrays of all lengths. So I create this counter sort of index variable, not an index variable, but a counter variable, I, which I've assigned to 0. And while samples at position I equals 0, I'm going to increase I by 1. Okay, so you could call this count. You could call this variable leading zeros if you want. Okay. And I've just made a little comment here that says this while loop counts the first n number of zeros. As soon as a non-zero value is found, we stop counting. So again, while samples at position I equals 0, you're going to increase I by 1. So the first time through the loop, I is 0. So samples at 0 does equal 0. Okay, as we can see here, in fact, samples at 0, samples at 1, samples at 2, and samples at 3 all have zeros in their positions, in their respective positions. So when we're finished with this loop, I is going to store the number 4 because there are 4 leading zeros in the array. Now, as I said, we can use that number to subtract it from, we're going to subtract 4, which is stored in I, from samples.length, that's the length of the original array, to give us the length of our new array, which we've called new samples. Once we've done that, we're going to use a for loop that's going to loop through the new array, new samples. So we just have a regular generic for loop header. J is assigned to 0 as long as J is less than new samples.length, J++, because we want to fill in every position in the new array. So new samples at position J is going to be assigned to samples at position J plus I. So I represents the number 4 in this particular, or given this particular scenario. So the first time through the for loop, it's going to say new samples at position 0 is assigned to samples at position 4. 0 plus 4 is 4. We don't want samples at position 0, samples at position 1, samples at position 2, or samples at position 3, because those were the leading zeros. We want to skip over those. So by saying J plus I, we've skipped over those, and we now can focus on the -14, the first non-zero value in the original array. And we'll continue to do that until we've run out of places to fill in the we've run out of positions to fill in the new samples array. So when we exit the loop, we then reassign samples, which was our original array, to new samples, which was the array that we had been filling. And in doing so, okay, go ahead and run this. Part B, the original array samples is 0, 0, 0, 0, -14, 0, -35, -39, 0, -7, 16, 32, 37, 29, 0, and 0. The new array of samples is -14, 0, -35, -39, 0, -7, 16, 32, 37, 29, 0, and 0. So it is precisely from here over. The new array is just what I've highlighted. It's from here over, so it gets rid of the however many leading zeros there are, and it says the length of the new array should be 12 and is 12. Okay, So that I did get from APCS Awesome. I just edited it to my needs using Replit. So part B, I have this S2, which is an array of integers. Okay, that was the example that was given. I created a sound object, which takes in an array of integers. I said system.out_print, the original array of sample is, concatenated with sample2. So I'm able to say just sample2 because in the sound class, I created a toString method. Okay, the same toString method that was invoked in part A. I then made a call to the trim silence from beginning method, okay, on my sound object. I then said system.out_println, the new array of sample is, concatenated with sample2 again. That was after the call to the method. And then finally, I did sopln, the length of the new array should be 12 and is sample2.array length. That was another method that I added to the class that would count how many elements there are in a sound object, okay, which happens to be an array of integers. And that worked out exactly the way we'd hoped it would, okay? So let me go back to the solution. Leave that up for a moment. And that's that. So it did actually take me a while to get that all sorted out in Replit. It wasn't as easy as, you know, I just made it look. It took me a while to get things sorted out because, again, the sound class that was given was not obviously complete. So I was just getting a couple different issues because I had to add the toString method and this array length method, okay? Any questions? The method was kind of confusing at first. Yeah, a little bit. Why did we use, what do you mean, Tanmim? I'm not sure I understand your question. Maybe you can rephrase it for me. Well, Tamim, without a constructor, your class is unable to create objects, right? It's not able to instantiate objects. So all I did was in the constructor, and I'll reshare my screen with you. Right, so what I did in the constructor, well, we were given a private instance variable called samples. Okay, samples is an array of integers. So so we have to initialize, we had to initialize the array of integers. And rather than initialize it to specific values, which is basically what they do in APCS Awesome, I didn't want to do that because then I'd have to go back into my sound class every single time I wanted to try a different array and have to reassign this samples to new values, okay? Which you can see in APCS Awesome. They do that in part A and part B, right? I didn't want to have to do that. So instead of doing that, we have a constructor that takes an array of integers, right? It takes an array of integers. Samples with a capital S is just a parameter, okay? So it's the name of the array of integers, and by creating an array of integers, which is what I did right here. So this is just in my main method, just an array of integers, and then by saying sound sample equals new sound S1, in order to create a sound object, you need an array of integers, okay? So I've just simply passed that array of integers to samples, and that now allows us to access samples throughout the rest of the sound class. We've done things very similar to this using array lists. But again, the way that they set it up was a bit different, and they had you assign the private instance variable to a specific array of integers. But the problem with that is you won't be able to test, right? You see the way I did it here, where I was able to test multiple arrays at one time. You wouldn't be able to do that if you followed the instructions they gave you in APCS Awesome. Okay? You're welcome. Are there any other questions? Any other questions about this FRQ? All right, so officially we have just over 1 week until the day of our exam. I'm going to go back to the main page here. So as requested, I posted the 14 FRQs that you should be going over and over and over and over again. So as of today, we've completed 1, 2, 3, 4, 5, 6, 7. So we've completed half, okay? That's not entirely true, because some of these you will see we already did earlier in the school year. I can't recall exactly which one. I believe we did 2014 number 1. Let me just double check. 2014 number 1. I believe we did it at some point. Yeah. We definitely did this question, the scramble words. So we did this question at some point, like much earlier in the year. Trying to see what else. There's definitely other questions that we've done. 2018 number 2 and 2019 number 3. We probably did those as well. APCS FRQ. 2018 number 2. Oh yeah, we did 2018 number 2 as well. Not that long ago. The word pair class with the word pair list. We definitely did this question when we did the list chapter. So you might not remember it, but we're going to do that one again. And then 2019 number 3.